Hi folks, today I'm going to be talking briefly about Asteroid 2014 RC, which flew by Earth on Sunday afternoon. Now I did make a video about this on Saturday, but as I was playing it back to myself, I heard myself make a mistake about the distance of the asteroid, and I didn't want to put misinformation out there, so I immediately took it down before it had accumulated even a single view. But some people who are less than honest are trying to suggest that I took it down after this Nicaraguan meteorite hit, and I guess they're claiming that I took it down because I was wrong about the asteroid missing Earth. Uh, that's not true. There are very dishonest people online, and the fact of the matter is, they didn't see that video, and I know they didn't because no one saw that video except me. I immediately took it down when I heard myself make a mistake as to the distance of the asteroid at close approach. That's the truth. That's the fact of the matter. So if you hear any of those people claiming that, I dare them to produce the video that I took down. They can't and they won't because they haven't seen it. And I took it down long before that so-called meteorite strike even happened in Nicaragua. So with that, here's the analysis I actually did do on Saturday before close approach. And I was hoping to view it, but as I feared, the weather did not cooperate all weekend, so I didn't get to see it. But a lot of astronomers did. Now, on Sunday afternoon, it passed by Earth, it went below the planet, and made its close approach at about 1/10 the distance to the Moon. And on Saturday night, there was a meteorite strike in Nicaragua that's currently being reported. I haven't seen absolute confirmation of that yet, but some people are wondering whether that was 2014 RC. And no, 2014 RC missed the planet as it was expected to. We knew it would. You can see the uncertainty region here. I performed a series of Monte Carlo solutions of the orbit, which form these little blue dots within the white line, and that is the potential positions of the asteroid at close approach. This data is from Saturday. This is from before the close approach, before the even before that event in Nicaragua. And you can see how tight these positions are. The green labels are overlapping at this point in time. But the condition code on Saturday was still a 5, and people are saying, well, how can you know it didn't hit Earth if the condition code is that high? Well, the condition code is an indicator of long-term uncertainty in the orbit. It doesn't tell you about short-term uncertainty. It could be uncertain in the short term, but not necessarily. And in the case of newly discovered objects, that's not really how it works. This is a newly discovered object, and as a result of that, the condition code is automatically going to be high in the period of time immediately after it's found. But in the short term, you can be very certain of where it's going to be, at least for the short term, for this particular close approach. We knew that the uncertainty region didn't even come close to encompassing Earth, and so there was no risk of impact at all. Now, if you look a year from now, if you fast forward this, I'm not going to change the magnification, just the time, and watch how the uncertainty region spreads out over time, because we didn't have many observations of the asteroid yet, so the long-term uncertainty was much higher, and now it's spread out to a region that's about the same diameter as the Earth-Moon system. And you can see all these blue dots have spread out, and we can be far less certain of where it is, and that is the concern with the condition code. If I zoom out here now, you can see we still have a good idea of the shape of the orbit and the general location within the orbit, but we're still far less certain than we would be in the short term. And the problem is, the longer you let that occur, the more spread out it becomes, and eventually it becomes difficult to recover the asteroid. So you can see they're spreading out not only in terms of distance from the Earth and the Sun, but also along the orbit. Because there's some uncertainty in the size of the semi-major axis of the orbital period has uncertainty as well. So the longer you go without observing the asteroid and nailing down those figures, the more spread out the uncertainty region becomes, because the higher orbits, the larger semi-major axis, will result in a longer orbital period. And so eventually these potential positions spread out along the orbit, and if that goes on long enough, you don't even know where it is within the orbit anymore. It could be, in any given point along the orbit, and you don't even know when a close approach is going to occur, only when the potentials for close approach occur. So that's the point at which the asteroid is effectively completely lost. Now, obviously that hasn't happened here, But that is why the condition code exists, to be able to triage asteroids and know which ones need observations the most, so that we don't lose them. Now, as for 2014 RC, it was seen after this apparent meteorite strike in Nicaragua. In fact, spaceweather.com has this picture on their front page today, and you can see the asteroid streaking through this image here after it supposedly struck Nicaragua. So clearly 2014 RC itself did not strike Nicaragua. Now, something else might have, but it wasn't this particular asteroid. Whether it was related to this asteroid in some way, some fragment that broke off, some people are saying, we don't have enough information to say that yet, but it clearly wasn't 2014 RC, and the asteroid did follow the predicted path. It did follow the predicted orbit, and it missed Earth, as NASA said it would. So that's that. I hope that sets a lot of things clear. I'll hopefully be able to webcast some asteroids someday when it's not cloudy and rainy. There is another one that spaceweather.com is talking about, which should be observable, and that is 2002 CE26. It's a binary asteroid. It might even be a strange trinary asteroid with not only a moon around it, a smaller asteroid orbiting the main asteroid, but potentially even another asteroid orbiting the smaller asteroid. So it's kind of an interesting case there, and I'll try to observe that if I can, if conditions allow. But for now, have a nice day.